Welcome back, viewers. We continue from where we stopped. In our last class, we treated the logarithm of a number less than 1. And we covered all of this. Treated these examples, exercises were given. Exercises as were given in the last class. You can go back to view what we treated in the last class. Finally, we are to go into multiplication and division of numbers less than 1. This class have been treated, but we've not made a video of it. I'll quickly run through this just to make the video available. What we treated in the class that was not presented in camera. Then we'll go to the next subtopic. Here are the examples we have here. Evaluate using logarithm tables, this and this. Now you notice the first one is an operation involving multiplication, while the second is division. Now, two methods were given, and we have the first method here. We also have the second method, which we'll treat later. Now, see method 1, using we have to express each number in standard form. And you remember how to express in standard form. If you don't know how to do that, you can go back to the former videos. So we have 8.907 times 10 to the power of minus 1. That is moving this here. We have 8.907 times 10 to the power of minus 1, because it was moved only once, times the same thing here. We have our point ought to be here, because the point is supposed to appear immediately after the first non-zero digit, according to the way the expression should be done if you have to express in standard form. So to do that, we move the point from here down to this place, which is 1, 2, 3. We move it 3 times, right? And we will have 6.792 times 10 to the power of minus 3. So you notice that from tables, we know that the logarithm of 8.907 is 0.9497, and the logarithm of 6.792 is 0.8320. So we are going to apply that. Since the logarithm of 8.907 is this, we can simply replace this with this. Logarithm means the powers to base 10, right? Generally speaking. So we have 10 to the power of 0.9497. This is 9497 written here. Times 10 to the power of 0.8320. That's the logarithm of this is this. Times 10 to the power of minus 1 times 10 to the power of minus 3. How did we get this? Instead of writing this, we wrote this, because it is the same. 10 to the power of this is the same thing as writing this. You get that? Then times 10 to the power of this is the same as writing this. So instead of writing this, we just write this to replace it. Now times 10 to the power of minus 1. Remember, we have this times 10 to the power of minus 1. This has been replaced with its logarithm. Then this has also been replaced with its logarithm. We just collected like terms, brought this and this together. We have times 10 to the power of minus 1, then times 10 to the power of minus 3. And which is what we have here. Do you understand that? Now, according to the law of indices, if you have something like this, I was explaining it here. 2 raised to the power of 10, for example, it means you have 2 raised to the power of 5 plus 5. You can also express it like this: 2 raised to the power of 9 plus 1, or 2 raised to the power of 3 plus 7. And we know that it is the same thing as this. That is to say that this expression, this particular one here, let me take this one as an instance, is the same as this, and it is also the same as this. You see that? We are respecting this rule of indices that say that if we have the same base, it could be expressed like this. Out of the powers, take the single base. Just take one of the base. And that means we can reverse it in a bit to solve problems. So let's come back on. Now that we have this, we can add up the powers, take a single base, and that means we have 10 raised to the power of this plus this power plus this power, then times 10 raised to the power of minus 1 plus minus 3. Where is this plus coming from? Because we have multiplication here. You see that? When the terms are combined with multiplication, that's to say that if they are to multiply each other, it means you add up their powers. But take note, that is when it is of the same base. Now coming here, this plus this is this. So we have 10 raised to the power of this times 10 raised to the power of minus 1 minus 3. How did I get my minus 3? Plus times minus is minus. You get that? Now, next step, it means we have 10 raised to the power of this, as you can see here, times 10 raised to the power of minus 4. How do we do that? Well, the sign rule will guide you. When you have minus 1 minus 3, it is like saying you are owing 1 unit. Let's assume in your currency, I will use the Nigerian naira. You are owing 1 naira, you are still owing 3 naira, hence the minus 1 naira minus 3 naira. That is minus 4 naira, right? So minus 1 minus 3 is minus 4. Another method you can use is this. You have minus 1 minus 3. Whenever you have two numbers like this having this negative sign, just bring out the sign and add up the digits. And that is, in this case, we have minus 1 minus 3. That is minus, open bracket, 1 plus 3, close the bracket. And then we have minus 4. That's minus 1 plus 3 is 4. That's minus 4. But you have to take note, just like I was emphasizing here before, that minus 1 minus 3 is not the same thing as 1 minus minus 3. There are different scenarios. Minus 1 minus 3 is minus 4. But 1 minus minus 3 is equal to 1 plus 3, which is 4. Do you understand? There are two different things. They are not the same. So let's come back here. We have minus 4. And that means we have 10 raised to the power of this times 10 raised to the power minus 4, which is equivalent to this. Notice we have 1.7817. Now I'm trying to break it down in a bit to get what I want. So I wrote 10 raised to the power of 0.7817. Instead of 1 point, I'm writing 0 point times 10 raised to the power of 1 before writing this. Now, what am I trying to do here? Take note of what I was expressing here. I was showing you something here. If you have 2 raised to the power of 3, it is the same thing as 2 raised to the power of 2 plus 1. It is the same thing as 2 raised to the power of 1 plus 1 plus 1. It is still the same thing as saying 2 squared times 2 raised to the power of 1. That is this particular one. If you have to express it in another form, this is what it means. Because this is only when you can pick the base and add up the powers, and it will give you 2 plus 1 here. In this case, this means you have 2 to the power of 1 times 2 to the power of 1 times 2 to the power of 1. And this is 2 to the power of 1 plus 1 plus 1. Irrespective of the one you choose to use, it will still give you 2 to the power of 3. So that's the logic I used. It means if you have 10 to the power of 1.7817, if we have 10 to the power of 1.7817, we can say this is the same thing as 10 to the power of 0.7817 plus 1. Since it is similar to 10 to the power of 0.7817 times 10 to the power of 1. You see the logic? This is just a reverse form of the solving. You can solve this to take you here, and you can also manipulate it to take you back here. So that's the logic used there. So we had this. Instead of this, I broke it down into this. 10 to the power of 0.7817 times 10 to the power of 1, then times 10 to the power of minus 4. And then that means we have 10 to the power of 0.7817 times 10 to the power of, remember the law of indices, we'll pick one of the base, add up the powers. So we have 10 to the power of 1 plus y plus, because of this multiplication, then minus 4, this minus 4 here. And that means we have 10 to the power of 0.7817 times 10 to the power of 1 plus times minus is minus. So we have 1 minus 4. This is 1 plus times minus equal to minus 4. 1 minus 4 is minus 3. Hence we got 10 to the power of minus 3. Now you may say you are lost, you are confused. How did you get the minus 3? Well, that's when you refer to your number line. If you have 1 minus 4, look at 1 here. Minus 4 means go to the left hand side 4 times. We have 1, 2, 3, 4. You see that? Where did it stop? Stop at minus 3. So 1 minus 4 is equal to minus 3. Now, let's continue. From the antilog tables, we can derive this. We know that the antilog of this number here is 6.049. Remember, convert this number that is in the form of logarithm back to standard form, the scientific notation. Now, how do you do that? You can go to the logarithm table, find the number whose logarithm is this. You notice that you find that under 60, that's 60 under 4 difference 9. You can watch the previous videos to get justice there. It is simple. You can do it. We did this several times in the past videos. So our answer happens to be 6.049. Then times the 10 is the power of minus 3. Did you see that? This now, we look for the antilog of this, and we got this. So we have this times 10 to the power minus 3. And then, of course, you know, this is how we are going to express it. If it is minus 3, it means we have 3 zeros before these digits. So we have this, and if you are to express in 3 significant figures, you are going to get this. You know how to round up. We have treated this in previous videos, and you know the reason we are rounding up to 3 significant figures addressed in the previous videos. Now let's go to the second example. The second example here is similar to the first example, except that this one is dealing with division. We have this divided by this. I decided to express it in this form. That is this divided by this. You know what I did here? Oh, this is the logarithm. We know that the logarithm of 8.89 is 0.9489. Do you understand that? So find the logarithm, which is this. Similarly, getting here, we'll find the logarithm of this, which is this 0.3109. Now, I choose to express it in this form. This is the numerator all over, that is the division. Instead of division, I use this sign all over this. which is my denominator. And this can also be expressed in this form. We decided to separate this. This is this divided by this times this divided by this. Similar. Now remember the rule of logarithm. When we have the powers of the same base as one of the terms being divided by the other, you can simply pick the base. Since it is the same base they have, pick the base and then you subtract the denominator from the numerator. That's denominator, the power of the denominator from the power of the numerator. And that's exactly what I did here. I picked one of the 10, then I have 0.9489 minus 0.3109. Now let's come to simplify the next step. We have times, you pick 110 minus 3 minus 2. How did I get a minus? I have division sign here. You see that? Hence this minus here. Now coming down here, if you punch your calculator, this minus this is going to give you 0.638. So we have 10 to the power of 0.638 times 10 to the power of, minus 3 minus 2 is equal to minus 5. You are owing 3, now you owe 2 again. This means you are owing 5. Or if you go to the number line, you can see it here. I gave an illustration here. See minus 3. See where minus 3 is located. Minus 2, that is 1, 2. You will land in minus 5. We have minus 5 somewhere here. So this is minus 3. Minus 2 means go leftwards 2 times. 1, 2. That's minus 5, right? So minus 3 minus 2 is minus 5. Now, the same thing we did earlier. Find the antilog of this, or go to the logarithm table and look for the number whose logarithm is corresponding to 0.638. You will get 4.345. Or you can let's put it this way: you will find it under 43, as you get 43 difference under 4, and then that's where you get your answer from. You understand? 43 under 4. Let me express it correctly for you. 43 under 4, then difference under 5. That's where you will locate that's how you will locate the figures corresponding to this, as far as looking for the antilog is concerned. Now we have times 10 to the power minus 5. Now notice that we have a characteristic as 4, right? So we need to effect it. How do we effect it here? If the characteristic is 4, it means we have 4.345 times 10 to the power minus 5 if it was to be logarithm. You understand? So let's not call this characteristic. This is not characteristic in this case because it is not logarithm now. We have taken it back to the number. Now, we have 4.345 times 10 to the power minus 5 if it is written in standard form. How do we effect it? Notice that I'm having about 5 zeros here. Of course, it is from here. We have 10 to the power minus 5. What that means is that I'm going to move this point to the left 5 times. Now let's see. We have 4.345. 4.345. Now times 10 to the power minus 5. So where the point is. Minus 5 means move to the left. 1, 2, 3, 4, 5. So your decimal point is going to be here now instead of here. And since numbers don't start with decimal points, put a 0 here first. Now this space is filled in with 0. 1, 2, 3, 4. Automatically you have 5 zeros before the 4. So you have 0.00004345 as a final answer, and that's how we got this. So 3 significant figures. So 3 significant figures should be 4, 3, 5. This is 4, 3, 4, 5. So 3 significant figures should be the 0.00043, round it up, become 5. That is so 3 significant figures. Here's the second method, method 2. This is the first question. We have to multiply this. You just create a table in a format like this, as you can see. Here you have your numbers here and log at the right hand side. So here we have 0.8907. You simplify them gradually. When you have 0.8907, if you see 0 point, obviously your characteristic is going to be bar 1. Characteristic for the logarithm is bar 1. Points, now go to the logarithm table, find 89 under 0, difference under 7. We've done this before. You can check other videos to know how to do this. So you see your multiplier is going to be 9497. Now if you do the same thing for this, here we have bar 3. You can see 3 zeros here. Remember, logarithm of numbers less than 1. So you have bar 3 points. Now if you have to find the logarithm of 67 under 9, difference of that to your multiplier will be 8320 here. Now since this is multiplying this, what you do is you add up the logarithms. Now let's add up the logarithms. 7 plus 0 is 7. 9 plus 2 is 11. Put down 1, carry 1. Down 1, this is 8. Now 1 plus 4 is 5. Plus 3 is 8. Put down the 8. 9 plus 8 is what? 17, right? Put down 7, carry 1. Now we have a minus 1 plus minus 3 is minus 1 plus minus 3. We treat this as minus signs in this case. So that is going to be minus 1 minus 3. Remember, when these two signs come together, they become minus. Minus 1 minus 3 is equal to minus 4. Right? Now that minus 4, remember that there is 1 that is left. You've not done justice to it. If you add that 1 to the minus 4, you will get minus 3. Minus 4 plus 1 is minus 3. You can go to the number line and do that. Now, since we have minus 3, you write bar 3. Don't write minus 3. You write bar 3. You have to take note that minus 3.7817 is not the same as bar 3.7817. And always remember to find your antelope. So we look for the antelope, which is this. How do we get the antelope? Go to your logarithm table, look for the number that is corresponding to this logarithm, and you will notice that you have to get it under 60. That's 60 under 4, difference under 9. So you have 6049 there. Now, how do we do justice to this characteristic? Bar 3 means we have 3 zeros behind the first non-zero digit. So you write your 3 zeros here. And the decimal point comes immediately after the first 0. And that means that this times this is equal to this, as you can see here. And if you have to express it in 3 significant figures, that is approximately 0.00605. You know, you are rounding up this into 3 significant figures. Example 2. Similar to the first one, except that this one is division. And since it is division, it means after looking for the logarithms for each case, that is for each number, you subtract the logarithms. Subtract the logarithm of this from this. That is, you subtract the logarithm of this one from this one instead of adding them together. After doing the subtraction, here is what we got. 9 minus 9 is 0. Subtract 9 from 9, you will get 0. 8 minus 0 is 8. 4 minus 1 is 3. 9 minus 3 is 6. You have a decimal point here. Minus 3 minus 2 is minus 5. Take your antilog using the step explained above or in previous videos where we did more justice to them, and you get this. And therefore we can say that this divided by this, which is this divided by this is this. You are approximate to 3 significant figures. That was that. Now we'll deal with operations with logarithms which are negative. That will be next topic or next subtopic. We have some exercises here and assignments. Yeah, you use logarithm tables to evaluate the following. So 3 significant figures and check the answers. So we have question 1, 4.986. Let me write this clearly. We have 4.986. This is number 9 times 0.0678. We have 0.0892 times 0.6798. Number 3 and 4. These are the answers as provided in the textbook which I'm using here. So after solving, you compare with the answers here and see whether you're on the right track. In case you like to get the textbook, this is the textbook being used. Juniors or senior secondary schools too. Very good book. Alright, thank you for watching. In our next video, we are going to deal with this topic. Operation with logarithms which are negative. God bless you. I'm Lucky Wajiro Organization Group. Stay blessed.